All right, so you've done a few mole conversion problems now that are one step each. And I mentioned toward the end of that video that there'll be problems now that involve using two steps, two different mole conversions in one problem. And basically it's exactly that. Instead of converting from moles to something or from something to moles, you're doing an extra step because you're not given right out of the gates moles, and you're not simply going to moles. You have to go from two more practical everyday units, one to the other. And moles is sort of the in-between step. So to get from grams of a substance to number of particles of a substance, or from liters of a substance to number of grams of a substance, it takes two steps. You have to first, as it says here, convert the amount you're given into moles, and then you'll convert something from moles now into another unit. So basically it's like the problems you've already done, taking two of those previous ones and putting them together. Grams to moles, you've already done that. Moles to liters, you've already done that, or something similar. So putting two steps together in basically one big problem, and I'll show you what they look like. Again, I've selected a few problems from your mole conversion sheet if you're in my class, and there are a few problems on there then that should have some little T arrangement boxes that help you to kind of position the units. If you don't like those, you can certainly go without them and not use them. I sort of put a few on there just to kind of show you how it's nice to organize your values, and it keeps everything nice and straight, and it keeps it sort of organized as you're getting a hang of these things first. It's up to you if you keep using them or not. Some people really like them. This is number 12. It's on the sheet there, and it asks you, it says here, to convert 2.3 liters of neon into grams. So you'll notice here in the problem, the word moles doesn't show up at all, but it's the in-between. We have to go from liters to moles, and then from moles to grams. Now, as you look at this, you might find that it could sort of be compacted into one problem, into one step, but we're going to show it very deliberately as two steps here, because as we go into true stoichiometry here, which is our next big topic, you'll find out you can't compact the steps and put them together into one. You must do every step very intentionally and very clearly. And so getting rid of steps and condensing the problem down is only sort of a short-term solution that won't help you in the long run. In fact, it'll give you some trouble in the long run. These problems start out the same as the ones that you were doing with me on the previous video, where you're doing one step. Same idea here. We'll start with whatever amount we're given, 2.3 liters in this case, and put it into the first box. Now, we're going to convert, as it says here, from liters to moles of neon. And just like in the last one, the last examples we did, we know that 1 mole of any gas, including neon, is 22.4 liters of neon at standard temperature and pressure conditions. Now notice I've put liters on the bottom so that it'll cancel out with the original liters that I was given. This middle statement where you're saying 1 mole equals 22.4 liters, it would be true if I flipped it over. 22.4 liters equals 1 mole. But if I put it in there upside down, then the units wouldn't cancel. It's really important that your units are diagonal from each other so they can cancel. So liters of neon will cancel out. And if I punch this into my calculator right now, I would get an answer in moles of neon. But I'm going to go ahead and just do my second step on the end, because this problem's not asking me for moles, it's asking me for grams. All right. So right now I would have moles of neon if I punch this into my calculator. I need to convert moles to grams. And so I need to know that, again, from my periodic table, that 1 mole of neon has a particular mass. And if you go look it up on your periodic table, it should be something in the neighborhood of right around 20 or so grams. I'm going to go with 20.18 grams of neon. As I've mentioned before, 1 or 2 decimal places should be enough precision in these problems. And again, like before, a unit is going to cancel out. So moles are on the top, and my numerator in the middle here, and I have moles in the bottom at the end of my problem, and those will cancel out. Moles on the top, moles on the bottom, and those units are gone. And now I've got nothing left but grams. If I go punch this into my calculator, it's going to be 2.3 times 1. And of course you can skip that because your calculator doesn't need to multiply times 1, but you're going to do it here sort of intentionally just to show you the process. And then times 20.18. So basically you multiply across the numerator, across the top, and then divide that by the whole quantity on the bottom. So divided by 22.4 times 1. Now, you don't need to use the ones, but I'm going to show them here because, again, as we get to stoichiometry, there won't always be ones there. I want you to be very intentional in your calculator. Take the numerator numbers and put them in a parenthesis, and then take the denominator numbers and put them in a parenthesis. a set of parentheses. Now, it helps you later if you get in the habit of doing this now. So all the numbers in the top divided by all the numbers in the bottom in 2 sets of parentheses, and you'll make far fewer mistakes. Okay. In the end, punch this into my calculator, and it should say somewhere around 2.1 grams of neon. My calculator, of course, doesn't tell me grams of neon, but that's the only unit that's left. That's the only unit that survived. Liters canceled out, then moles canceled out, and in the end, all I had left right here were those grams of neon, and that became the unit on my answer over here. And the numbers gave me the number 2.1. So in the end, 2.1 grams of neon is my answer for sample problem number 12. All right. So I did 2 conversions from liters to moles and from moles to grams. Let's look at another one that's similar. Number 21 says 10 grams of calcium, 10.0 grams to be precise, of calcium. So I'm going to put that in my first box. And the instructions kind of guiding you through it here say first convert grams of calcium to moles of calcium. All right. Well, if I'm going to convert to moles, then my 1 mole of calcium needs to go on the top. And again, if you look back at the previous example, it's almost always going to be 1 mole and 1 mole when we're doing simple conversions as we're doing here. Now, how many grams of calcium are in 1 mole? You should be able to go to your periodic table and look that up. Something right around 40. Sometimes people will use 40 or 40.1. I'm going to go ahead and use 40.08. Again, you could use 40.1 and pretty much get the same answers. Now, grams of calcium are on the top, so they cancel with the grams of calcium I just wrote on the bottom. And again, if I went to my calculator and punched it in, I'd have an answer in moles, but I'm not quite done. So let's go one more step. This question asked me to convert to atoms. To do that, I'm going to need to use Avogadro's number, that big honkin' 6.02 times 10 to the 23rd atoms of calcium per mole. So 1 mole of calcium goes in the bottom because I want my moles to cancel out and leave me with atoms in this case. And again, Avogadro's constant says that there are 6.02 times 10 to the 23rd calcium atoms in 1 mole of calcium. It's 40 grams. It's 6.02 times 10 to the 23rd atoms of calcium, but they're all equal to 1 mole of that calcium element. And so in this case, 1 mole on the top will cancel with 1 mole on the bottom. And in fact, you could cancel out the ones too, I suppose. I generally don't tell you to cancel out any numbers because people get in the habit of accidentally canceling out numbers when they're not ones, and then they start getting into trouble. So I won't say cancel out the ones, even though your calculator and your work, those of you with really any math skills at all, are going to cancel ones out and just kind of ignore them when it comes to punching them into your calculator. They don't carry a lot of weight when we're multiplying and dividing, right? So if I go to punch this into my calculator like before, I'm going to multiply across the top 10. I'm going to go ahead and write it out for you one more time. Times 1 times the 6.02 times 10 to the 23rd. Now, this is an important number to know how to punch into my calculator if I'm using my scientific notation mode, right? And it's also tricky sometimes to figure that out in your calculator if you haven't been doing scientific notation very much in your math classes. So hopefully we've found it on your calculator and you know how to punch that in. Otherwise, you might have to ask someone near you to help you, or just skip any problems that involve particles until you get a chance to see me. But what I've set you up here for then is 10 times 1 times the quantity 6.02 times 10 to the 23rd, which is Avogadro's number, and then divided by the denominator 40.08 times 1. And again, the ones can be ignored, but we'll show them here for detail's sake. And in the end, my calculator is going to give me the answer of 1.50 times 10 to the 23rd, okay, calcium atoms in that quantity. Now that's a lot of particles, that's a lot of atoms. And my significant figures come out as 3 significant figures. So 1.50 times 10 to the 23rd calcium atoms in 10 grams. And I've converted it through 2 processes then, from grams to moles. I could have stopped and got an answer there, but we went one step further. We converted those moles to atoms, and it's 1.50 times 10 to the 23rd calcium atoms. Now, if you looked at your calculator screen after punching this in, and you just see the 1.50, some folks don't even realize that there in smaller, usually smaller characters on your display, is the power of 10. So if you don't have a graphing calculator with many lines of text, you might have to look off to the side of your display screen there on the other calculator and look for the times 10 to the 23rd, usually in smaller font or in smaller characters. Don't overlook that. A lot of people aren't used to looking for it, and when they're coming up with atoms, they get ridiculously small numbers, like 1.50 atoms. Well, that doesn't make any sense, right? So we need a power of 10. So watch for that when you're working with moles and quantities related to the mole, because occasionally you'll have that power of 10, and you'll miss it if you're not looking for it. Let's do another example here that doesn't involve particles, in case you're having trouble with your calculator not helping you to find those the scientific notation commands. And again, I'll help you out when I see you next if you are. This one's number 15 on your sheet. It says I've got 0.23 grams of P2O5. So that's diphosphorus pentoxide. And I'm going to convert those 0.23 grams to liters. And again, 2 steps. First, convert the grams to moles, then convert the moles to liters. So I'm going to convert to moles. I need to put my 1 mole of P2O5 up here on the top. And on the bottom, some number of grams of P2O5, right? So go to your periodic table, and you can add up P2O5, and you should get an answer somewhere around 141.95 or even 142 grams of P2O5 in a mole. So that's 2 phosphoruses and 5 oxygens all added together. You should get 141.95. Phosphorus is right around 31 grams for each one, and then 5 oxygens at 16 apiece. So if you go to add that all up off your periodic table, hopefully you're able to get to these numbers fairly consistently. Again, 2 times around, it's right around 31 grams. I forget the exact number, but 31 grams or so for the phosphoruses, and then 5 times 16 or so for the oxygens. And in fact, I think if I add this up, it comes up pretty close to that. So maybe double check your numbers on the periodic table and see if you're getting something close to that. If you are, then you're in the right neighborhood. I think phosphorus is about 31 grams. All right, so in the end, grams will cancel grams, and that leaves me with moles. And again, we're going to go one more step here. So convert moles to liters. That means 1 mole of any gas is 22.4 liters. So this time I want to get rid of moles, so it goes in the bottom. 1 mole of P2O5 has a volume of 22.4 liters of P2O5. And my moles will cancel out. Moles, cancel moles. Go to my periodic table, or go to my calculator and punch this all in. 0.23. Again, I'll just put parentheses in my box now. Okay, 0.23 times, if it's next to it, you're multiplying, times 1, times 22.4, and then divide by the whole denominator in parentheses as well. 141.95 times 1. So multiply across the top, divided by the quantity across the bottom, multiplied together. And for this one, we should get an answer right around 0.0363 liters of P2O5. Now we're running a little bit out of space there, but remember, you always want 3 parts: a quantity, 0.0363, a unit of liters, and then the substance, P2O5 in this case. So there's my answer for number 15. All right. Now, there are several others on there that are 3 steps, or 2 steps rather, where you start with something like grams or liters or atoms or molecules, and you convert to grams or liters or atoms or molecules. Well, you're going to have to go through moles, and again, those are 2 steps. So first, convert whatever you're given into moles, and then convert those moles into whatever you need, which should be some other unit. But like in the first video that we did on conversions, if you're given moles or if you're asked to convert to moles, you should be able to get it in just 1 step. And those were the easier first ones that we did. If for today you're only comfortable doing the 1-steppers, that's fine. Just nail down the 1-steppers and you'll find out that 2-steppers are always simple after that. I can't 2-step, but I can do a mole conversion problem that has 2 steps. You'll find out later as we go on to actual stoichiometry that you'll be doing even problems that have 3 steps to them, and it'll be no sweat at all, because you'll be so good at it by then that it'll be like an old hat. So work on a few of these, even again if it's only the 1-steppers, but get brave and try a few of those 2-steppers. And if you can't figure out your scientific notation function on your calculator, ask someone near you or your math teacher how to punch those in, or I can help you when I get back and see you the next time in school. Talk to you then.